Now we can relabel this graph using any point and assigning any y value and x value to that point. So what I'm going to do is, well, we could pick any point at all on this graph. We don't have to pick the same one we picked here, but it'll be a little neater if I do pick the same point. Actually, I'm going to go off camera and debate that for a second. No, I take it back. I'm going to pick another point where I'm not going to be duplicating any of these points. And I'm going to pick this point here, which I'm drawing in orange to match the color of this question. Okay, so at this point, I'm going to choose to let x equal 4 and y to equal 12. Now, if I cut 4 in half, that's going to put me about here. So the label at this point will be 2. A little bit difficult to draw that real low on the board, but there it is. And of course, we go to half of that and we get 1. That was a little easier to draw. Okay, so there's a couple of coordinates. Okay, and 12, okay, we could cut that in half, or we could cut it in thirds. A little easier to cut it in half, especially since the board is kind of cluttered. So let's see if we can just kind of do that. Okay, let's see, is this point about halfway to 12? Yeah, it's a little high. So 12 is going to be just a little bit under this white line here. That white line segment, of course, was one of the segments we used in constructing the graph. It doesn't correspond to any scale at all. And I'll put a 6 here, indicating that this corresponds to y equals 6. And then I could cut that down to half. And let's see, this point would be a little bit too high. So I'm going to say that, let's see, this point here, how does that work? It's a little low, so I'm going to say that 3 would be about here. Okay, now, again, I could choose any point and put any numbers on it I want, except that 12 times 4 to the 3 halves, well, 12 does not equal 4 to the 3 halves. If I put 12 in here and 4 in here, it doesn't work out. Okay, 4 to the 3 halves is around between 5.6 and 5.7. 4 to the 3 halves is not equal to 12. Okay, so let's just say the ballpark 4 to the 3 halves is around 6. Then 4 to the 3 halves would give us 6, not 12. How could we get around that? Well, we could get around that by changing the function slightly and making it y equals 2 times x to the 3 halves. Okay, that would still be, as it turns out, in the same family as the power function x equals 3 halves. Okay, we have a whole family of power functions, and we're going to say that family is the family of functions that you get for any possible relabeling of this graph. Now, of course, 2 wouldn't be an exact result. For if x equals 4, if y equals 12 and x equals 4, we'd have to multiply x to the 3 halves by just a little more than 2. And we'll work that out in a minute. So what we're going to say is that now y, instead of equaling just x to the 3 halves, is equal to some multiple of x to the 3 halves. And we're going to try to figure out what that multiple is. Okay, now as I write this out, I realize I did a bonehead thing. 4 to the 3 halves is not 5.6. 5.6 is about 4 times the square root of 2, and 4 to the 3 halves would be 4 times 2. Anyhow, we do the algebra here, and we realize that 4 to the 3 halves is 8. Now, you should be able to do that yourself, and I'm not going to write the details here. I'll probably write them off to the side here at the very end. 4 to the 3 halves means 4 to the 1 half raised to the 3rd power. 4 to the 1 half is 2, square root of 4, and if we raise that to the 3rd power, we get 8, not 5.6, as I said before. So we get A equals 12 divided by 4 to the 3 halves which is 12 divided by 8, which it turns out is 1.5, which coincidentally is 3/2, and that was just kind of an unintentional coincidence, and that's not something that's generally going to happen. Okay, in any case, for this function, turns out that a would have to equal 1.5, and I can say that we can label this graph now so that the purple graph, and I hope nobody's colorblind, but the graph labeled with the 1 and the 0.5, the graph labeled with the 2, the 1, and the 0.5 here is y equals x to the 3/2, and the other graph, the one in orange, is y equals 1.5 x to the 3/2. Had I chosen other numbers, different points, again, any x value, any y value could be used to label any point, but then the rest of the graph would have to follow that labeling. And if we want to know what the function is, we're probably going to have to put in some multiple here, unless the numbers happen to fit y equals x to the 3/2. I'm not going to label the graph for this, but let's suppose y is 12 when x is 3. Now you could easily pick another point, another point on the graph, and label it x equals 3, y equals 12, and go from there. If that's the case, then we know from what I've said here that y is in the form a times x to the 3/2, and we need to evaluate a. Well, all we do is we plug in x equals 3 and y equals 12, and we evaluate a. So 12 would have to equal a times 3 to the 3/2, so that a, well, you solve it and then come back and see if I've got it. Okay, so let's see. See if we agree. If we don't agree, then see which one of us is wrong. Actually, I started to write something very wrong down here. You look at 3 to the 3/2 in the denominator, and you want to make that 3 to the 2/3 in the numerator, but that's clearly invalid. But I almost wrote that down. Now, I wouldn't have persisted with that, because then I would have checked myself out at the end and realized there's an inconsistency, and I would have gone back and fixed it. Anyhow, okay, so we had this, and ask you to solve it from here to here. Well, we divide 12 by 3 to the 3/2, we get this. What's 3 to the 3/2? Well, that's 3 to the 3rd raised to the 1/2, which is the square root of 3 to the 3rd. So now we have 12 divided by the square root of 27, because 3 to the 3rd is 27. And let me just say, I'm afraid that I see smart people reaching for their calculators to raise 3 to the 3rd power, and that's just shouldn't be happening. Okay, wean yourself of the calculator for things that you can do in your head more quickly and with greater understanding. Okay, now, so anyhow, that's 12 divided by the square root of 27, and we rationalize that. And that's 12 times the square root of 27 divided by 27, and then we can reduce the 12 over 27. They have a common factor of 3, and that reduces to 4/9. So we have 4 times the square root of 27 over 9. Now, if you're doing this for a lot of practical purposes, you will then probably approximate the square root of 27. And the square root of 3 is 1.732, so you get 5.196 when you triple that. Anyhow, so if you do square root of 27, I think you get 5.196 or something very close to it. Okay, well, and square root of 3 is another number you should simply know. Okay. It arises a lot in trigonometry and a lot in other places. One way or another, then, our model would then be y equals 4 square root of 27 over 9 times x to the 3/2. And that would go along with these numbers. So that would give us this model. So if we labeled one point on here as 3 for the x, 12 for the y, then our graph would represent this function. And you can, of course, approximate this function, I think this number might come out around 2.3 or something like that, to a degree that fits the application you're trying to model. If the application requires a lot of precision and if your data is very precise, then you would want to carry this out to more significant figures than if your data is just, kind of fuzzy. So maybe just going to the nearest tenth would be good. Maybe you need to go out to the nearest thousandth. It depends on the situation. So a final statement is that y equals ax to the 3/2 is the family of power 3/2 functions. It's what you get for p equals three halves. If you construct the p equals 3/2 graph with the constant multiple 2 to the 3/2, approximately 2.8, you get a graph that could be relabeled to show any member of this family. Okay? Every member of this family will be a relabeling of that graph, and any relabeling of this graph will give you a member of this family. Now, I'll say just a little more, but in a subsequent video.